Good morning, all. Is the screen and voices audible? And screen? Answer attendance say using 3 parameters. Okay. So once again, good morning, all. This is the video lecture on design and analysis of algorithms. So we have finished with the module 2, divide and conquer strategy. So now we are going to discuss with module 3, greedy method. So as you all know, there are 3 algorithm techniques: divide and conquer, greedy method, dynamic programming, and backtracking. So in that we have finished divide and conquer in module 2. So now we go with a module 3, greedy method. So how you solve the problems using greedy method. Okay. So in that we shall go with outline of the entire greedy method module 3. So first you will get the concept like introduction to greedy method. So in that you will go with a general method, coin change problem, knapsack problem, job sequencing with deadlines. So these are the 4 topics what you get under greedy method. So greedy method will have general method is the first concept. So then comes applications where this greedy method are used. So first problem is coin change, second knapsack, third job sequencing. Okay. So next you come for the next minimum cost spanning tree. So there you will get Prim's algorithm and Kruskal algorithm. Next single source shortest path. In that you will get Dijistra's algorithm. So all these are the lab set programs for you. Okay. So all these things you will be having lab set, knapsack, job sequencing, coin change, Prim's, Kruskal, Digitra, Huffman code, Gibson. All the concepts are the lab set programs. Okay. So Prim's, Kruskal, next Digistra's, optical tree, you will get Huffman tree and code. So finally, you will get transform and conquer approach. In that you will get heap and heap sort. So these are the concepts you will be having. So this is the brief outline of the module 3. So module 3 you will have all these concepts. Understood. So now you come for the in that first concept what you are going to discuss in today's class, it is only the general method. So next first you understand the method, then you can easily go with all the remaining concepts. So all these are the applications. First you go with a general method. So what is the general method tell? So go through the concepts what I have told here. So greedy approach suggests constructing a solution through sequence of steps. So now you have to compare divide and conquer with greedy. Okay. So constructing the solution by not dividing. There is no concept of divide here, through sequence of steps. So you will construct the solution through sequence of steps. Second, expanding a partially constructed solution obtained so far. So you will construct the solution through a sequence of steps. Okay. So after that, now you go with a expanding a partially constructed solutions until complete solution is reached. Okay, so first step is construct the solution using sequence of steps. Next, expanding the partially constructed solution obtained so far until a complete solution to the problem is reached. Okay, so that this is the general approach for brief general method. So on each step, the choice made must be, so you are constructing a solution, expanding the solution until complete solution is found. Okay, so in each step, the choice made must be feasible. That means it has to satisfy the problem constraint. Constraint means condition. So whatever you give, it is the word feasible. It has to satisfy problem constraint. Second, locally optimal. It has to be the best local choice. It has to be the best local choice among all feasible choices available on that step. Optimal means, so it will be the best solution. Optimal solution means best solution. So it has to be the best choice among all feasible choices available on that step. Irrevocable. Once made. Irre means again. Irrevocable means once made, it cannot be changed. So once made, it cannot be changed on subsequent steps of the algorithm. Okay, so what are the greedy method will suggest? Construct, then first step is to construct the solution through sequence of steps. Second, expanding the partially constructed solutions obtained so far. Next, until so far, keep expanding until complete solution is reached. So at each step, so the following things are to be made. So which are those? One is feasible, second optimal, irrevocable. So these are the conditions or constraints of the general method of greedy technique. So these are the general method of greedy technique. Okay, so come for the in detail general method. So this is the brief outline I have told you. So coming for the general method, first given n inputs. So how many inputs are given? N inputs. Choose the subset that satisfy the constraints. Okay, so many inputs are given. You have to choose subset. That means, so set of inputs are there. So from that you choose some of the numbers. Suppose if there are n is equal to 10. Okay, so if n is equal to 10 inputs, choose the subset. So subset can be 5. Okay, so that should satisfy the constraints. A subset that satisfies the constraint is called feasible solution. So keep this one. Now we are going to look with these three concepts: feasible, optimal, irrevocable. So given the n inputs, you choose the subset, and the subset that satisfies the constraints is called feasible solution. So what are the constraints you have? So constraints can be any conditions depending on the problem. So I will tell you what is a constraint when you go with the example. So n inputs, you choose the subset. If subset satisfy the constraints, it's called feasible solution. So feasible means it has to satisfy problem constraint. So if it satisfies the problem constraint, we call it as feasible solution. Now after that, come for the word optimal. Optimal means the solution that maximizes or minimizes the given function is said to be optimal. Optimal means maximum you will go for minimize word. So feasible solution that minimizes the given function or given objective is said to be optimal. Okay, so often it is easy to find the feasible but difficult to find the optimal. So you can easily find the subset that satisfy the constraints. That is easy. But minimizing or maximizing the given function, it is difficult. That is the third step what you are going to have. It is easy to find feasible solution, but difficult to find optimal solution. So this is the general method. So now you come for the general algorithm of greedy technique. So what is the general algorithm of greedy technique? So greedy, an array A. What is A? It is an array. Array A with n inputs. So n inputs. So here you can see A is array. Array A 1 colon n. So it contains n inputs. Okay. So array is range. What is A? It is an array name. What is the values? 1 to n. We call it as range. 1 to n contains n inputs. Okay. Initially, solution is equal to null. So initially, what you have? Solution is given as null. Initialize the solution. So I is range of, you have to go with each and every elements. So array A is starting at 1 and it is ending at n. So for I is equal to 1 to n, do x. What is x? Subset. So what is the first step you have to go? From n inputs, choose the subset that satisfy the constraint. So select of A. So inside that you select the subset. So select of A, we give it as X. What is X? X is the subset of A. So X should be, we tell X as fusible if it satisfies all the conditions. So subset that satisfy the conditions or constraints is called as a fusible solution. So here we take what is A? It is an input. So inputs are ranging from 1 to n. In that you create a subset. So subset is given as X. Okay, X is the subset. So okay, so if it is subset is there, if fusible of solution comma X. So if fusible of solution comma X, then solution is equal to union of solution comma X. So this is the condition for checking the feasibility. Okay, so you have taken the subset. So first step is to, from n inputs, choose the subset. So what is the subset? So subset we take it as small x. So small x is the subset. N inputs. So n inputs means you are taking it from where? So you are taking it from input A. So 1 to n. So once you take the subset x, so once you take the subset x, next thing is to make it feasible solution. So how to find the feasible solution? Using this condition. If feasible of solution comma x. If x is feasible in, if x is feasible, place it in solution. So that is nothing but feasible solution. So if x is a x, what you have taken the subset is meeting all the conditions, place it in solution. So that's why we take it as solution is equal to union of solution comma x. Okay, so this is only for checking the feasible thing. So from 1 to n, you will find all the solutions. And finally, which is the optimal one, that is the return solution. This is the optimal solution. Okay, so you can see here the solution that maximizes or minimizes the object function is said to be optimal. So first step is finding the subset. Second step is making the subset fusible. So fusible thing is there. So this will happen for I is equal to 1, I equals 2, I equals 3 up to n. So you will have all the values up to n. So once you find all the solutions for I equals 1, you take one subset. So I equals 2, you take another subset and do the union, and which is the smaller one. Which is the smaller one, you consider this as solution. So solution is, here it is not feasible solution, here it is optimal solution. Optimal means minimum or maximum of all the solutions, we take it as optimal solution. Okay, so understanding? Are you people getting? Yes, answer here. Are you people getting? Okay. So, have you understood the general method? Yes. What is step one? So there are two or three steps total, two steps. Okay. So in that, which is the step one you have? Step one of greedy. So what is the step one of greedy? Feasible. So feasible will be the step two. Step one. Yes. What is the step one of greedy method? Amita came. Amita. Okay. Aishwarya, yes. Aishwarya, yes. Harshini, yes. Harshini, yes. Neha, MK. So many people are not there in the class. Okay. It is no use asking questions. So, Neha, MK, tell me the step one of the greedy method. Initialization of what? Okay, you can see here, step 1, from n inputs, choose the subset. I am telling again and again. Kindly go through, given n inputs, choose the subset X. Okay, so second step is, once you choose the subset, once you choose the subset that satisfy the constraint is called feasible solution. So first step is, from n inputs, choose the subset X. So second step is, a subset that satisfy the constraint is called finding the feasible solution. Third step is, from all the feasible solution, you find the optimal one. Totally 3 steps are there in the greedy method. So n inputs, choose the subset. Second step, the subset that satisfy the constraint is called feasible solution. Third step, from all the feasible solutions derived from all the subset. So if there are 3 elements, how many subsets you have? So anybody can answer. If there are 3 elements, how many subset? If n is equal to 3, how many subsets you have? Just I am giving, if n inputs are there, so how many subsets you have? 9. How 9 subsets? How many subsets are there? Can you tell? 2 power n. Okay, good. So if the n is equal to 3, so 2 power 3, how many subsets you have? So you have, it is 8. Okay. So 2 power 3, it is 8. So first you will start with null. Next you keep on increasing 1 combination, 2 combination and 3 combination. So it is 2 power 3, only 8. It's not 9. It's only you have 8 subsets. Okay. So take each subset. So take each subset and find the that satisfies the conditions of the problem. We call it as feasible solution. So for subset 1, subset 2, subset 3 up to subset 8. So 8 subsets are there. So you find the feasible solution. So that when you tell it as a feasible solution, if that subset will matches the constraint, we call it as a feasible solution. A subset that satisfies the condition of the problem, we call it as feasible solution. So 8 subsets, you have 8 feasible solution. Okay, so each feasible solution, which can be minimum one or maximum one, is said to be optimal. The feasible solution that minimizes or maximizes the given function is said to be optimal. Okay, so it is easy to find the feasible solution, but difficult to find optimal solution. Same thing we have seen here. Initially, how many inputs are there here? 1 to n inputs. So have you find the solution? No. So initialize to 0. Next you start from subset each. For I is equal to 1 to n, you from the array A, you select of A. So select of A means you select the subset. So 1 to n are there. So suppose I gave 1 to 3. So how many? 3. So how many subsets you will get? So it is x. So subsets is nothing but x. So if n is equal to 3, so you will have x1, x2, x3 up to x8. Okay. So now you start taking each and every x. X1 comma solution if feasible. So initially solution will be null. Nothing will be there in the solution. If feasible of solution comma x. So then you write it as, so then you will be writing it as solution is equal to union of solution comma x. So this is the statement to find the feasible solution. Putting the, if feasible, then put that particular solution. If the subset what you have taken is meeting all the conditions, then place that condition into the solution. So similarly, you do for x1 is done. Next, you put x2. X2 is mapped feasible with a solution. Then you place. That's why you have given it as union. So you can remember this is a shorthand assignment operator we have taken. Solution is equal to solution union solution comma x. So keep placing all the solutions into solution. Union we have taken. Okay, so how many feasible solutions you find here? So 8 feasible solution. If n is equal to 3, you will find 8 feasible solution. So all the solutions are placed using union operator. X1 union X2 union X3. Sorry, for x1 solution will be solution 1. For x2 subset you will find the solution 2. If for x3 you will find solution 3. So x8 you will find solution 8. So totally you put all the union and you find minimum one or maximum one. So minimum one or maximum one. So that one we call it as return solution, that is optimal solution. So first solution is feasible solution. Second solution is optimal solution. So this is the concept. Okay. So first step. This is n inputs. You choose the subset x. So for each subset, so you find the which satisfy the condition we call feasible solution, and which is minimum or which is maximum one is said to be optimal solution. So understood up to here? Understood? Have you understood? So answer for my question, how many types of solutions we have in greedy technique? How many types of solutions we have in greedy technique? So there are 2 solutions. Can you tell which are those? Two solutions, feasible and the other one? Union is the operation. Your operation what you are going to find choosing all the solutions. So, so if n is equal to 3, how many subsets you will get? If n is equal to 3, you will get 8 subsets. Okay, so 8 subsets. So x1, x2, x3 up to x8. So how many feasible solutions? If n is equal to 3, so how many feasible solutions you will get? Let's answer here. If n is equal to 3, how many feasible solutions you will get? If n equals 3, how many subset? 8 subset you will get. For each subset, you will get one feasible solution. So how many feasible solution for n is equal to 3? Yes, anybody can answer. If n is equal to 3, how many feasible solutions you have? For subset that satisfy the constraint is called feasible solution. How many subset? 8 subsets you are having. For 8 subset, for one subset you will find one solution. For 8 subset you will find 8 feasible solutions. Okay. So from 8 feasible solutions, how many optimal solution you will find? Yes, answer in the chat box. For n equals 3, 8 subsets. So for 8 subset, how many feasible solution and how many optimal solutions? Yes, answer in the chat box. So for each subset, you will be having one feasible solution. Okay, for 8 subsets, you will be having 8 feasible solutions. Okay, so once you 8 feasible solutions, but when you go with a last optimal solution, okay, it is 8 feasible solutions. After telling you are answering. So for 8 subset, you will find 8 solutions. So this is called feasible solution. So you do each and feasible solution 1, union feasible solution 2, union feasible solution 3, up to feasible solution 8. So in that, which is the minimum one and which is the maximum one? So that one particular feasible solution, we take it as optimal solution. So ತುಂಬಾ ಕಡಿಮೆ ಇರೋ ಸೊಲ್ಯೂಷನ್ ಯಾವುದೈತೆ ಅಥವಾ ತುಂಬಾ ಜಾಸ್ತಿ ಇರೋ ಸೊಲ್ಯೂಷನ್. So my minimum solution or maximum solution, that value you are going to take it as optimal solution. So how many optimal solutions we have? You go with a minimum value or maximum value. So all solutions will be a number only. So when you go with all of them, you will get to know. So how many optimal solutions you will be having? So if you are placing all the feasible solutions, which is the minimum one, that is only one solution, which is the maximum one, that is only one solution. So that is here what we are returning the finally, it is the optimal solution. Okay. So understood up to, I hope you all got understood this particular topic. So this class is up to general method of 3D technique. So in the next class, I will go with the problems. Okay. So where these 3D techniques are used. I hope you all got understood. So go through the videos in the YouTube channel. Understand all the concepts and algorithms. So kindly like, share, subscribe for the channel for getting all the notifications of videos. So thank you all. Stay home, stay safe.